In this video, we'll be looking at sets, inequalities, and interval notation. So let's go ahead and get started. It says, describing sets of numbers. We can use any of the following ways to describe a set of numbers. So before we get into that, I just want to do a quick review here. These are symbols that you should be familiar with just by looking at them. So make sure that you're comfortable with these. So that's the less than symbol. We read it as less than. This will be less than or equal, greater than, and greater than or equal. So make sure you can read those correctly, whatever that takes. Okay, so we have a number of different ways to describe a set of numbers. We're going to talk about 4. So first of all, we could use words. And we could say, okay, x is less than or equal to 3. X is less than or equal to 3. So we could use words, or we can use what we call set notation. Now, we know that x is less than or equal to 3 looks like that. It's just, what is all this other stuff, these brackets and things? Well, with set notation, we use the brackets to emphasize the fact that this is a set of numbers. And actually, let me make some space here. So let me show you how we read this. It's read the set of elements x such that x is less than or equal to 3. So the set of elements x such that x is less than or equal to 3. So notice we read this symbol such that. Now normally we're just going to be using x is less than or equal to 3. But you should be, well actually when you're seeing your answers in my math lab, they're going to have the braces with the set notation. If you were doing a test and you put an answer without the braces, I don't really care about that. All right, so we have a third way, but before we do look at interval notation, we're going to look at graphing on a number line. So if I'm graphing the numbers, or I should say, if my set is the numbers x that are less than or equal to 3, or if we're graphing x is less than or equal to 3, we're graphing the numbers that are either less than 3 or equal to 3. So you can see in my graph here, these are all the numbers less than 3, and we're including 3 in our set, and so we actually have what's called a bracket. This is called, so it's a bracket, and we say this is closed-ended. Is it close-ended? Close-ended. Boy, I should know that. Close-ended. And that's where we have a bracket. That means the end point or the end value is in the set. Now, some of you may have seen this in the past, where you're at 3 and they use a dot, and since we're including the 3, they'll make it a solid dot and it looks like that. And so that means the same thing. The difference is, notice how interval notation looks very similar to the graph, and I think that's why they're doing the graph this way these days. Notice on the left, this arrow on the left indicates we go forever left, which approaches negative infinity. So -1, -2, -3, -1 billion. It goes forever in the negative direction. And so we call the concept there is negative infinity. And so the thing about interval notation is it's always read left to right. Always read left to right. And so we're starting at negative infinity, we're going to 3, and at 3 we have a bracket because we're including 3 in our set. All right, let's look at B. Y is greater than 4. Of course, that's how we would read this. And so we have, we can write it in words, we can write it using set notation. Now, Y is greater than 4, that's this graph here. Notice we're using a parenthesis. This is what we call open-ended. which means the 4 is not part of the set. Basically, the numbers start right after the number 4. So that's a picture of the numbers that are greater than 4. And then you can see interval notation going from left to right. We start at 4, not including 4, and going forever right. That's the idea of the numbers just get bigger without n. So we're approaching infinity is how we say that. And so in interval notation, we're going from 4 to infinity. And again, we're open-ended on the 4 because we're not including 4 in our set. All right, and then finally, let's look at C. It says x is a number between -2 and 3. Now that's the way I like to say it, but the more formal way to say this is x is greater than -2 and less than 3. Now first of all, I want you to see something here. If I write 2 is less than 3, that is certainly true. We could actually read this backwards and it would be read 3 is greater than 2. So when I read this symbol backwards, it's read as a greater than. Now normally when we look at this expression, we're going to say 2 is less than 3, but it's also correct to say 3 is greater than 2. And so we can read it the other way and it has the same meaning as 3 is greater than 2. All right, so when I look at this, so we have x is greater than -2. Notice if you read this part backwards, it is saying x is greater than -2 and less than 3. X is also less than 3. So x is both, or x are the numbers that are both greater than -2 and less than 3. Let me just erase this here. So isn't that what we have here? The numbers that are greater than -2 and also less than 3. Or the other way to say it is the numbers between -2 and 3. All right, and so notice when we write it in interval notation, it looks like a point if you didn't know any better. But in this context where we're talking about interval notation, this is the numbers between -2 and 3. All right, so I'm going to go ahead and go to the next slide. And I'd like you to try 1 through 4, see if you can, well, notice it says graph each of the following on a number line, then write using set notation and interval notation. And actually, I'll go ahead and start the first one with you here. I would actually say go ahead and write this. Well, it says x is less than 1. Let's just write x is less than 1. And again, I'm not going to worry about the braces here. And so I'm going to go ahead and graph the numbers. Actually, you know what? I think I already wrote that out. So x is less than 1. So let's go ahead and graph that. So I'll put a couple numbers on the number line. And the numbers that are less than 1 would be the numbers left of 1. Now, is 1 in our set? No, because we're graphing the numbers that are less than 1. X is less than 1. So we're going to use parentheses here. And so that's the graph of the numbers that are less than 1. Now, writing in interval notation, remember you start on the left. Well, we're in negative infinity territory here. And then we go to the right and we eventually get to 1. And again, it's open parenthesis at 1. All right, so see what you can do with numbers 2 through 4 and then check your answers. All right, so let's see how you did. X is greater than or equal to -1 and less than 2. These are the ones that are a little bit tricky to write in set notation. The way I do it is I'll write my x, and I know that I'm going to put x between two numbers. I want to put the smaller one on the left and the bigger one on the right. Now notice it says x is greater than or equal to -1. Well, we're going to have to write this backwards. It's going to look like that. Notice if you read this expression backwards, it does say x is greater or equal to -1, and at the same time, and less than 2. So x is less than 2. And so that's how you would write this. Now, if you were writing it in the fancy, formal way, it would look like this. The set of numbers x such that x is between -1 and 2, counting -1 but not 2. Or x is greater or equal to -1 and x is less than 2. All right, so these are the numbers between -1 and 2. So let's go ahead and graph those numbers. Now notice because of the equal sign over here, x is greater or equal to -1, we're going to use a bracket at -1. And here x is less than 2, so there's no equal sign there. We're not including the endpoint, and so we have a parenthesis here. So now let's write this in interval notation. We're going from left to right, -1 to 2. So notice how similar these look, but a little bit different. All right, let's see how you did on number 3. So x is greater or equal to -3. When you graph that, those are the numbers greater than -3. Notice -3 is in the set because we have x greater or equal to -3, so we'll use a bracket here. And going from left to right, we start at -3, we go forever right, that's what we call infinity. Now notice with infinity, we always put a parenthesis next to infinity, and that's because there is no last number. Infinity is a concept. It's the idea that you're going forever right. If you came in tomorrow and you said, Mr. Smith, I just found the biggest number, I have discovered the biggest number ever, I would ruin your day by adding 1. There is no biggest number. That's the idea of infinity. All right, number 4, all real numbers. Well, that's everything. That's all the numbers that are on the number line. Now, it doesn't look very sophisticated, but this is how you would write all real numbers in set notation. The set of numbers x, such that x is a real number. Not very impressive. We sometimes use this symbol, it's like a capital R with 2 legs, to represent all real numbers in set notation. Now, let's go ahead and graph this. This would just be the whole number line. And so in interval notation, which is the method we'll usually use, it's the one we'll focus on throughout this course in college algebra. So -infinity to infinity. All right, let's move on. So actually, I think I'm going to stop right here, and we're going to move into solving inequalities next.